So now we have variables from the PLC imported to the HMI project. During the import, they've changed their names to tags, but that is not as important as what we can do with them. Suppose we want to let the operator know, somehow, that there is a VS default. There is a corresponding tag with a Boolean type. Let's visualize the tag on a screen. If you think about the whole HMI project as an illustrated album, which depicts your machine or a process, then the HMI project's pages are like pages of the album. When you create the new project, a default page called page 1 is automatically generated. It matches the resolution of the operator panel you selected earlier. You can obviously create more pages, but we will do it in later chapters. For now, let's work with the one we have and start filling the blank canvas. To do that, we use the widget gallery. A central toolbox where you'll find all the elements you might need to build a page. To display something Boolean like fold state, you go to Lights folder and select any of the available widgets. Rounded light with label will do the work. Just drag and drop it onto the white canvas area, and that's it. You've added the widget. In CP600, every widget is treated as an object with a set of properties. You can see them in the Properties panel if you select the widget. For example, the Label property lets you change the text displayed on the widget. The Value property controls whether the widget is on or off. Set it into 1, turn it on, typically changing its fill color. The Color property defines the set of colors the widget uses based on its value. Let's say the red color doesn't look red enough and you want to adjust it. Just click the small button next to the color field and choose a new shade from the palette. Right now the widget is just a static element. You can only change its state manually by modifying the Value property. The magic begins when you link that property to a tag. To do that, click the plus button next to the property you want to link. The panel builder will then display all the tags currently defined in the system. You can see alarms variable list, which acts as a container for underlying tags. The one we need is called XVSDefault. Select it and hit OK. Now the widget state will automatically reflect the value of that tag. Let's also make the panel a bit wider so you can see the full tag path clearly. Here's another way to link a property to a tag. If you click the A button next to the plus, you'll open the same data link field, but this time it's blank. That means you'll need to manually type the full path to the variable. It's definitely less practical than the previous method, but in some cases it can be useful, especially when you want to copy-paste it from elsewhere. And that's the core principle behind building a dynamic HMI application. Dynamic meaning that widgets respond to tag values in real time. But I haven't told you the whole story. Even simple widgets like this light have many more properties than we've seen so far. You can reveal all of them by clicking Show Advanced Properties button. Here's the cool part. Any property with a plus button next to it can be animated with a tag. That means you can do things like link font size to a tag so it grows or shrinks dynamically. Bind the tag to a widget's X or Y coordinate to make it move. Change its size, rotate it, blink, or even make it disappear. I think you get the idea. Okay, in theory, everything should work, but how do we actually check? The most straightforward way is to load the project onto a physical panel and see what's happening. And yes, we'll definitely do it, but not just yet. Instead, we can use a simulator, which provides pretty much the same capabilities as a physical panel. First, save the project, and then either click this button or go to Run Start Simulation. After compilation process finished, you'll see the interface we have designed. At the moment, there is no real data exchange with the AC500 controller, because the communication driver is also being simulated, which means that if you press on this tag simulation button, you'll get something like Automation Builder's watch list. Find the XVS default tag, change its value to 1, and you'll see the light widget react, just like it would on a real panel. But here's where simulation gets really powerful. Since we're using an Ethernet-based protocol and the PLC is on the same network as a PC, we can connect to the real PLC and get live data from it. All you need to do is open Simulator Settings, uncheck Use Simulation, and voila! The simulator starts pulling data directly from the AC500 PLC. If I press the emergency stop on the drive, it will go to fault and the state of the light will change. The only problem is we can't reset the fault, at least for now. Let's change it. Go to Automation Builder, find Drive Control Function block, find Reset Input. There's nothing connected. Go to Variable List HMI and create Reset Drive Fault variable and then bring it to the function block input. Next part you already know how to do. Update symbol configuration, update symbol file, go to Panel Builder and import the tag. Now we need to add a widget that doesn't just react to a variable, it actually changes the variable's value when pressed. Sounds like a job for a button. Any type will work, so let's go with the rounded blue button. Resize it if needed, bump up the font size a bit, and add some meaningful text. Next, link the value property of the button to the tag you want to control. If your variable list is too long to browse comfortably, use the filter to quickly find the right one. There's also a property called click type that defines how the button behaves. Momentary, the value stays 1 only while the button is pressed. Maintained, each press toggles the value between 0 and 1. For a reset function, the momentary option is usually the better fit. Alright, let's give it a try. Disable the driver simulation, let it reload, and something is not right. Basically, this exclamation mark in a triangle is a sign that there is something wrong either with the device we try to connect to or with a specific tag we link to a widget. What might it be? Well, in this case, the problem is that I haven't uploaded the project changes to the PLC. If you go to Automation Builder, log in and do online change, then go back to the simulator again, you will see that the yellow triangles are gone and there is a fault signal. Press and reset button will clear the drive fault. Yay, it works. But resetting a fault is just the beginning. Let's make something actually run. To do it, we need at least to put pumps 1 and 2 to auto mode. Once that's done, the system will check whether other control conditions like supply water temperature are satisfied. Add 2 static label widgets and put their tags to pump 1 and pump 2. This helps visually separate the widgets that belong to each pump. There are different ways to do the same thing in Panel Builder, but to show auto manual switch state, I'd like to use Message widget. In Properties, find Messages and then press plus, then add remove message. By default, the Message widget has 4 index values with corresponding text messages, but we only need 2. Set the text for index 0 to manual and for index 1 to auto. You can play with value property to see how widget looks like in different states. Now link the widget to the actual tag, X auto pump 1. For pump 2, simply duplicate the widget and update the data link to the corresponding tag. Next, let's show whether the pump is actually running or not. While we could reuse the light widget from before, for learning purposes, let's create an indicator using a basic shape, a circle. Hold Ctrl while scaling it to keep the proportions uniform. Make stroke width 0 so we don't need to deal with stroke color and concentrate only on fill color. Link the circle's fill color to the tag xRunVSD_pump1. Before clicking OK, head over to the color palette section. This lets you assign specific color based on the tag's value. For example, set the running state color to blue and the stop state to a gray shade. Okay, now just swap the colors. When you press OK, data link along with the tag will also include a color palette custom function. This function returns a color hex value based on the tag's current value. Now simply duplicate the widget for pump2 and update its data link accordingly. And finally, let's display the actual motor load or torque. Add a numeric field and link it to... we haven't imported analog values. No worries, let's fix it. Go back to symbol configuration, select analog I/O, then build the project, generate code, and load the changes into the PLC. Once that's done, return to the tag selection and import all the analog I/O related data. Now you can see how the structured tags come into the project. Great, now we can link the numeric field to the actual value. Find the actual torque tag and select it. Before hitting OK, there is one more thing I want to show you, this scaling section. This lets you adjust the numeric value by either applying a formula or specifying input and output ranges. For example, if torque value came directly from the drive, it would be between 0 and 10,000. And the range we would like it to be scaled to is 0 to 100. In our case, though, we've already handled scaling in the PLC application. Just below the data link section, you will find properties that let you tweak how the number appears on the screen. Try changing the value to something like 99.5 and set the number of decimal digits to 1. You'll see the display update accordingly. Cool, start the simulation. Disable driver simulation, reset the wheel's default, then switch pump 1 to auto. The indicator should change state to auto as well, and after a short delay, the drive will start showing the actual torque. Switch it back to manual and repeat the same steps for pump 2. Yep, it all works exactly as designed. That's it for today's chapter. While everything we've covered is pretty basic, the core mechanics won't change throughout the course. The panel receives data from external sources and links it to on-screen elements, making your HMI dynamic and responsive. Be safe. I'll see you in the next one.